think you gotta wait another minute until they all come in. Yeah. Well, good afternoon, everyone, and welcome to MetalCon Live. It's really great to have you with us today. I'm Judy Geller, Director of MetalCon, and I'm here with Kaylin Burke, who is manning the controls. Today, we bring you Cladding Safety in Light of Global Fires, presented by the Metal Construction Association. MCA membership can help you strengthen metal's position in the construction industry while delivering many benefits to your company. For details, please contact Jeff Irwin at 614-595-4330. Before we begin, just a reminder that MetalCon is just a few weeks away, but there is still plenty of time to register. And granted, it's a bit of an unusual year, but we do have a lot planned. In addition to 175 exhibitors, 40 education sessions, we are introducing the Solar Education Center, the Insulated Metal Panel Pavilion, Contact, the Construction Technology Pavilion, and for the first time, we are now offering the Architects Experience. This is an exclusive experience and opportunity for architects, specifiers, and engineers to discover the most exciting new applications of metal in design and construction. It includes exclusive education, an architects-only exhibit hall tour, and an evening off-site tour to the Dali Museum with a reception, a keynote by Jan Weymouth, its architect, a reception, transportation is included, and it should be a really exciting evening out. Architects can save 50% off their registration for the Architects Experience and the Dali Tour. They just go to psmj.com/architect and enter the coupon code TAEFL. By the way, we welcome architect students to attend for free. They would register using code ARCHSTU. For more information, you can go to metalcon.com, send an email to info@metalcon.com, and also the slides that you are seeing will be sent to you along with your digital recording after this session, so you can reference them there. We hope you will join us at MetalCon. We have a plan in place to keep everyone safe. You can take a look at our health and safety protocols on our metalcon.com website. And now just a final reminder, if you need any technical help, reach out to MetalCon support in the chat box. And don't forget to complete the post-webinar survey in order to earn your AIA HSWs for today's session. That's all I have, and I'm gonna hand it off to Tom.
Thank you, Judy. We are extremely honored. I'm trying to get this thing up here on the share screen here. Share, there we go. Thanks, Judy. We're extremely honored to be here for today's MetalCon Live webinar. As Judy said, I'm Tom Seitz, the Executive Director of Metal Construction Association's MCM Alliance. Probably your first question is, what is the MCM Alliance? Well, we are an MCM industry leading manufacturers, fabricators, and suppliers of MCM materials and systems for the North American architectural marketplace. We proactively work together, providing the construction industry with clear and concise product performance testing, publishing of MCM-based research papers, and we're participating in all the IBC code compliance forums. The Alliance embraces the ongoing mission to help educate architects, consultants, code writers, and building owners on the many advantages of MCM facades and ensuring the future of MCM in the North American architecture. The next question is, what brought this conversation to the forefront to have this webinar on cladding safety in light of global fires in the first place? Well, too many global high-rise fires. And just to mention a few, Tamwell Tower in Dubai, the Marina Torch in Dubai, and we all know of Grenfell Tower in London. Just 2 weeks ago, I wake up to emails and texts regarding fires in Italy and China. And because there's metal on them, the media starts with another Grenfell. I recall New Year's Eve, December 2012, turning on the news and seeing a fire occurring at Tamwell Tower, which was the first major fire to hit, and the media calling attention to a fire issue with MCM. 5.5 years later, in June of 2017, I get the news when traveling in Western Canada with a fabricator of the Grenfell Tower and the horrifying results of that fire. And just a side note, none of those wall assemblies, as installed, would pass an NFP 285 multi-story test. We as an MCM industry had no good response, but by October of that year, we began to formulate our plan within the MCA structure and started the MCM Alliance in January of 2019. And here we are today in front of you with our timely topic about cladding safety. One of our questions that keeps coming up is, are we just lucky in North America? Well, luck has a way of happening when you're doing the hard things the right way. And the NFP 285 is part of that story. And the trust that's been developed over the last 40 years in our North American testing and code process. Our MCM industry is a growing one. And one of our missions is to help educate the construction industry on what our testing has done to earn the trust to use more MCM on our architectural facades. After all, building envelope has a few basic requirements: the management of heat, air, and water. It handles wind loads. It captures the aesthetic design vision that the architect has for his building owner. It's supposed to meet the local codes and give a 30 to 50-year lifespan. Okay. Understanding how to meet all these complex challenges can be very confusing. There's a value for MCM on the facade, and it comes in many different ways. It's design versatility, it's functionality, testing, and it's a highly rigid yet lightweight and flat material. This webinar's purpose is simply to help understand the value in the NFP 285 multi-story test and its overall performance of a wall assembly in the real, and I mean real world analysis. The NFPA is all about safety and no threat to life. And the NFPA 285 tests the construction wall assemblies containing combustible materials. Today's HSW credit webinar learning objectives are: what does the NFP 285 tell us about cladding performance? Helps give an understanding of the relationship between continuous combustible insulation, the weather-resistant barriers, the WRBs, the location and size of the cavity space, information on the MCM cladding there, and the NFP 285 requirements. Number 3, when the 285 applies per the IBC requirements. 4, when the engineering evaluations are an alternative, a necessary alternative. Number 5, what trust in the NFP 285 means to you, the architect, the engineer, and the owner. Now I'm going to be turning this program over to Paul Deffenbaugh, the Editorial Director of Modern Trade Communications, which publishes Metal Construction News and Metal Architecture. We're very happy to have Paul part of this program, and Paul will moderate this discussion on cladding safety in light of global fires. But before I turn this over, I'd like to make a request, just as Judy had done. At the end of this program, please stay on for a brief survey, as we really would appreciate your feedback. And if you have any questions, please put them in the Q&A. We'll be getting them at the end of this program. Thanks again for being here. And Paul, it's all yours.
Hey, great. Thanks, Tom. Good morning, everyone, or afternoon, depending on where you are. I'm really looking forward to what should be a great and knowledgeable discussion this morning or afternoon. That's because we have a great panel of experts, and let me take a moment to introduce them. Dan Martin is a fire protection engineer with Jensen Hughes. Andy Williams is the Metal Construction Association's Director of Codes and Standards and serves as technical advisor to the MCM Alliance. Nick Scheib joins us from 3A Composites, where he serves as Vice President of Sales and Marketing. And we also have Jeff Henry, who is the CEO of CEI Materials, a company that fabricates MCM. Thanks to all the panel for joining us and bringing your talents. And I want to remind everybody, with such an array of talent, I'm sure you're going to want to take advantage of their knowledge. So please ask questions. We're going to respond to the questions at the end of the webinar, but I suggest you submit them as we go along while they're fresh in your mind. We're here to discuss cladding safety in North America in light of global fires. So let's start there. Internationally, in the past decade, there have been several large and catastrophic fires, as Tom alluded to, and that's made designers, architects, and code officials question if we're at high risk here in North America. In particular, the Grenfell fire in London, which killed more than 70 people, had disastrous results. With this in mind, I want to ask each of our panelists to help me understand if we need to be worried. And Dan, we're going to start with you. With your expertise in fire engineering, can you explain some of the reasons that Grenfell's results may have been so catastrophic? And in particular, please speak to the material selection and wall assembly.
Yeah, sure thing. Before I answer, Paul, I just want to make sure it's clear to everyone that's on this call that the government's investigation in England into this fire and what happened and all the players and all the things involved, it's still ongoing. 2017, 2021, they've only released the phase 1 findings of their investigation. So things are still evolving as we get through this fire and how the government does their investigation with their testimonies and depositions. So we don't have the full picture, but we've got a little bit of a picture of what happened. The short answer to this very loaded question is that the exterior wall assembly was constructed and designed in such a way that it was not compliant with the building regulation of England. If anyone's familiar, the approved document B. And ultimately, it failed the British test, which is the BS 8414 test, when BRE did a series of tests post Grenfell Towers with the materials that were on Grenfell. So it failed their own test. The exterior wall did incorporate 2 different types of exterior insulation. It was polyiso and phenolic. The MCM veneer that was on the building itself had a polyethylene, or what we call in the industry a PE core, that did not have any flame retardant additives, or FR. And that's something that you'll hear coming up between PE and FR later on. Also, the cavity barriers were not continuous behind the veneer. There's a cavity barrier requirement in the UK, and they were not continuous. And the exterior wall geometry of how the panels actually were formed and how it looked from the street created very large air gaps between the insulation and the MCM panels.
So Dan, beyond the wall assembly and the material selection, are there any other factors? Were there any factors that could have contributed to the negative outcome in this fire?
So everyone saw what was played on the internet, the newsreels and the newspapers, pictures of fire on the outside, but not many people had a good grasp of what was going on the inside. So based on some of the phase 1 findings, the phase 1 inquiry findings, the building itself was not fully sprinklered. So no sprinklers to try to control the room and contents fire that initiated this event. There was only one centralized stairwell for evacuation. Several of the fire doors used for compartmentation were found to be propped open or did not operate properly to create that compartmentation that their building regulation is based on. Also, the natural gas and electric to the building was not shut off for nearly 24 hours after the fire had started. And some the fire service tactics that were chosen right off the bat were shelter in place instead of evacuation of the building. So there's several things that went on that we didn't know of immediately after the fire that we're learning through this investigation.
Thank you. Hey, let's turn to Andy, who's our code expert on the panel. Andy, can you explain if this kind of assembly would meet the requirements of the International Building Code or National Building Code that we follow here in North America?
Good afternoon, Paul, and thank you for the opportunity to be part of this panel. The simple answer is no. Back when the first full-scale tests were developed, there was an additional criterion for heat content in the wall. The PE Core MCM did not comply with this requirement, and a new product was needed to be developed. This was the birth of the FR Core MCM panels. Today, in order to meet the requirements of the code, almost all high-rise construction is done using FR Core MCM, where the assembly meets the code requirements, including NFPA 285.
So that helps us understand how the Grenfell Tower wouldn't meet our building code in North America. What about other fires, like the ones in Dubai? That one was unfortunately named the Torch Building that burned twice. Would those buildings have been have met our code?
Yeah, I can imagine that the developers wish they had come up with another name rather than the Torch Building, but the answer is still the same. PE core panels were used on all of these other products. If the projects would have been built in North America, the PE product would not have been allowed for use, unless there was some way found that the wall assembly could meet the requirements of the current code.
Nick, your company manufactures metal composite material panels. Can you speak to the PE material, and is it still available in the North America market?
Oh, yeah. Number one, Paul, thanks for having me here today. And that's a great question. PE or polyethylene material is still manufactured in North America, but it's primarily used for signage and canopies. Now, it does meet the code requirements on some low-rise buildings under certain conditions, but most manufacturers primarily produce fire retardant MCM material. It is the predominant material used for commercial construction, particularly high-rise, as the FR. And we do this in order to meet the IBC life safety requirements, specifically NFPA 285 and a properly designed wall assembly. This FR material really helps reduce risk should there ever happen to be a fire.
Well, should there ever happen to be a fire, have there been significant fires with MCM in North America, Nick?
Again, that's another really good question. So as Andy stated, I want to reiterate, none of the international buildings that experienced these massive fires would have met North American building code requirements. When I was asked to be part of this panel, Paul, I had my team do some research to see if we could find any examples, whether good or bad, of fire retardant materials that were in a fire. And we were able to uncover 4 fires in North America through a lot of research. There was the Adair fire in DC, State Teachers Union in Ohio, the Marine Gateway Tower in British Columbia, and lastly, we found a Smith fire in British Columbia. Each one of these fires were insignificant. On the 4 incidents that we were able to find, there was very limited flame spread and there was very little damage. Most importantly, the fire was quickly controlled and there were 0 injuries. So ultimately, these were examples of wall assemblies that were designed to NFPA 285 and or the Canadian S134 test, and they performed very well in these real life examples and these real life fires.
Those are great points, and it seems like the NFPA 285's a major key to understanding why North America hasn't suffered from these catastrophic fires. Is this the code, Andy, that's the same for both Canada and the United States? And is it the same for every state, every city?
Well, the codes are the same regarding intent. The end goal is to limit flame spread up the exterior wall of the building. In the United States, we measure that using NFPA 285. In Canada, the test used is the ULC S134. There are some differences between the 2 tests, including sample size, the way the fire attacks the wall, and the pass-fail criteria. But at the end of the day, it's all about flame spread. Another common thing about the codes in the United States and Canada is that each code covers the entire country. In the US, we use both the International Building Code and the Life Safety Code. In Canada, the primary code is the National Building Code of Canada. Each state or province in Canada adopts the nationwide code with modifications to address specific concerns in their area. These are often called local amendments. To make things even a bit more confusing, major cities like Los Angeles, New York, Chicago, and Toronto further amend the code to address their local issues, such as the difficulty of fighting fires in a very tight space. The bottom line is that flame spread over a building or between buildings remains the major concern in all cases.
Well, I understand the code's different in Canada with the S134 testing, and it's similar. It's also clear that requirements in the state cities may be different. I'm going to recommend, but for the sake of today's presentation, we're going to focus in on the NFPA 285. So with that in mind, Dan, how do you define a 40-year history of the NFPA 285 and cladding performance? Round that up for us.
Ooh, that's a tall order. That's a great question. Honestly, it would take me more than a day. I mean, we could sit a full 8 or 10 hour day to sum up everything we've learned as an industry and barely break the surface, let alone try to get into it in this hour-and-a-half presentation. But I would define it as a massive undertaking by everyone. I'm talking about architects, manufacturers, the test labs, the engineers, the developers. I mean, we're all in this together, and we've been doing this together for the last 40 years. We've done thousands of tests as an industry and thousands of combinations of different wall assemblies over the last 40 years to give us that good idea of how things burn and how things burn together. All this testing has left us with a strong understanding of fire performance and flame spread in the exterior wall environment.
Andy, what's the NFPA 285 tell us about cladding performance?
The NFPA 285 gives us a real world, at least size-wise, sample that shows not only how the components perform, but the length of the test and the real world construction can show the interaction of the different components and the overall impact on flame spread. NFPA 285 is about more than just the cladding material. Items like combustible insulation, the depth of the air cavity, and even the weather-resistant barrier can be evaluated. It's a really difficult test that has been in use in the United States for quite a long time.
It's been in use for quite a long time, 40 years, I understand. Has it changed in that last 40 years?
Well, there's a timeline, and while the dates on the timeline are important, the real reason for this large-scale test was to show the flame spread of a combustible wall. At the time, the concern was foam plastic insulation that was used for energy conservation. But we soon realized that any combustible was an issue and that flame spread was important. The original test was a full-scale two-story building with cladding on two sides. The cladding was exposed to flames produced by burning a 1,500-pound wood crib and breaking out a window. But there were a number of built-in issues in that initial test. The test was outside and affected by the elements. The wood crib did not burn exactly the same each time, and there was only a single test facility in the United States, which led to long testing lead times because some finishes need up to 30 days to cure on the wall before testing. This led to a more standardizable test, which included a gas fuel source, an indoor test to eliminate the weather variables. However, the sample needed to be scaled down to fit into the test building. The biggest problem was that we can scale down the sample, but we can't scale down the fire. The heat from the gas fire inside the burn room could not provide the same level of insult to the cladding without being a major explosion hazard to the lab. The lab guys were kind of against this. So that exterior burner was added to make the insult to the wall the same in both tests. The rest of the changes made up to the early 2000s were basically administrative, getting us to the NFPA 285. That doesn't mean the test we use today is the same as was developed in 2000. The test is reviewed by committee every couple of years to address concerns and new ideas that make the test relevant to construction today. The latest significant change was made in 2019. When the location of the vertical and horizontal joints was defined to create a worst case test. Joint location was all over the place, and we knew that the joints were often the easiest entry for flame behind the exterior cladding. Talking about flame spread, both the vertical and the horizontal flame spread is a pass-fail criteria in the NFPA 285. The whole point of this large-scale test is to determine how far flames will spread from the fire source. Limiting the flame spread, both on the surface and within the cavities, will minimize both damage and threat to life. Vertical flame spread is probably the key criteria for pass-fail in the NFPA 285, and it's limited to about 10 feet above the window opening. There is quite a bit of smoke created by the gas during the test, so flame spread is measured using thermocouples, where a temperature of 1,000 degrees Fahrenheit is considered the temperature where active flaming is taking place. Horizontal or lateral flame spread is also considered and also measured by thermocouples either 4 or 5 feet from the center of the window opening. There are several variations of large-scale testing used throughout the world. These tests involve different fire sources, test wall sizes, and test durations. What we do know from 40 years of experience is that MCM wall assemblies successfully tested to NFPA 285 have never performed badly in a real-world fire, and that the flame spread is limited as shown in the testing. We also know that changes to a wall assembly can impact the overall performance in the NFPA 285 test. Tons of information, and like Dan, I could spend a bunch of time in this area, but that's kind of where we are and how we got here.
Hey, thanks, Andy. I keep hearing that word combustion in your answer, and maybe it's beneficial for us to dig into that and understand it a bit more. Webster's defines combustion as able to catch fire and burn easily. Is that what it means when it comes to building materials, Dan?
Yes and no. It depends on which code you're actually looking at. The definition in how you determine combustibility varies. The codes differentiate the allowable uses of a material when it's combustible versus non-combustible, depending on the situation, depending on the building. So it's important to understand how the code determines when a material is considered combustible versus non-combustible. So it's kind of yes and no.
So in the code, what does define combustibility?
Well, like I said, it depends on the code. So for example, I'm going to look at the IBC or the International Building Code. There is no specific definition for the term combustible in the definition section. So when that occurs, you revert back to the definition per Webster's dictionary. Now, with that being said, if you look in IBC, there is a section where a material can be considered non-combustible if it is tested to ASTM E136 or ASTM E2652, and you meet the acceptance criteria of E136. So ultimately, if you fail ASTM E136 combustibility test, it's a small scale test that looks at the material itself. If you fail that, you're considered combustible. But there's some little quirks and exceptions in every code, unless you meet the exception in the code, like a gypsum wallboard. There is a fine exception there, but you're looking for that ASTM E136 test result.
So what's the NFPA's life safety code definition?
Excellent. Yeah. So if you're looking on the other hand, you look at NFPA 101, which is the life safety code used in various states. I know there's some in the Northeast. And healthcare, it gives a more of a building environment specific definition for combustible. And you have it, which is a material that in the form in which it is used and under the conditions anticipated will not ignite and burn, a material that does not meet the definition of non-combustible or limited combustible. So NFPA 101 also uses the same two previously mentioned standardized tests to determine non-combustibility. So we're looking at a material that in the form in which it is used and under the conditions anticipated will not ignite and burn. So a little bit different than the Webster's dictionary definition. So that kind of gives you an idea of how things kind of change between the codes you're working with.
Dan, give us some examples of non-combustible materials and combustible materials we might have around us and encounter frequently.
Yeah, absolutely. So let's just start off with non-combustible. Your concretes, your steels, some of your mineral fiber insulations, aluminum, spray fireproofing, the SFRM you see on steel, cement fiberboard, the natural stones, clay brick, etc. Those are your non-combustibles. Now on the flip side, we'll get into the combustibles, your wood, your flame retardant treated wood, or also known as FRTW, foam plastic insulation, the water resistive barriers, PVC pipes, carpeting, furniture, the clothing you're wearing, high pressure laminate veneers or HPLs, EIFS systems, PE core, polyethylene core, MCM panels, FR core, MCM panels. That's what you're seeing in the built environment, or a couple combustible examples.
So I think I know the answer to this question, but are all combustible materials the same? Do they each have the same amount of flame propagation potential?
Excellent question, Paul. Absolutely not. Flame propagation, also known as flame spread, and combustibility, those two concepts of flame spread and combustibility are two completely different things. Every material ignites and burns differently, and we need to evaluate that. So in some instances, the combination of two different burning materials will result in a flame spread that is drastically different than if I was burning that two same materials separately. So for example, in exterior walls, we have the MCM panels and we evaluate their flame spread with 285. And in that 285, we're testing that as a combination of materials.
Hey, Nick, your company manufactures ACM. In particular, I know that you produce the Alucobond Plus, which is FR. Can you explain what the FR means and how that's different than the PE, which I understand was used in the catastrophic fires we were talking about earlier?
Yeah, no problem, Paul. Sure thing, I'll go over that, and hopefully you can hear me well. I had to turn off my video. I'm having a little bit of internet connectivity issue, but
We can
FR stands for fire retardant. Oh, wonderful. FR actually stands for fire retardant, not fire resistant. This is commonly confused, but there's an important difference there. Fire retardant core not only burns more slowly, but it actually retards the flame due to how the core is made up.
So how is a fire retardant core made? Nick, did we lose you?
Okay, well, I believe there's a slide supported on the screen. So which is aluminum trihydrate or magnesium oxide in the core, and these minerals break down when they're subjected to extreme heat, and that water vapor helps suppress the fire and causes the minerals to self-extinguish once that flame source is removed.
Nick,
Are we able to catch?
We're catching you. It's a little off and on, but let's continue if we can. Does the FR material burn?
So yes, like I said, it will burn if it's subjected to a fire source, if there's a source on it, such as the gas burners in an Nfpa 285 test. The FR core will burn slowly, and it's designed to self-extinguish once that flame source is removed. And I believe we'll be showing a video of this later, and that will definitely help demonstrate this powerful characteristic of the FR MCM.
Hey, thanks, Nick, very much. You mentioned the Nfpa 285 test in your response. We've been talking about it. I think it's probably beneficial for us to get into that testing procedure a bit more. Dan, let's start with the basics. What does the Nfpa 285 determine?
Yeah, for sure. So as Andy talked about previously in his history of Nfpa 285, 285 is the standard fire test method that is used to determine vertical and horizontal flame spread of exterior wall assemblies that contain combustible components. It's right there in the title. What we're doing is we're evaluating the flame spread across the face of the wall. We're evaluating the flame spread within the wall cavity itself. Then we're also evaluating flame spread from floor to floor. So flame spread per the test standard is limited vertically to 10 feet above the window opening, as Andy said, and laterally either side of the window opening center line by 5 feet. So the key word here that I want to keep emphasizing is that this is an assembly test. This is not a component test. We are looking at the assembly as a whole when doing an NFPA 285 test or an evaluation.
So what kind of test is it? And how's it set up?
So this is an intermediate scale test. As I said, that is evaluating the exterior wall assembly flame spread performance when exposed to an interior fire that has become fully developed or post flashover with a fire plume that is breaching out of the opening in the wall. As you can see on your screen, it's got two levels to it. The lower level being the burner room, and then an unoccupied room on the second level. So this 30-minute fire exposure is achieved via two burners. In this picture, you can kind of see both of them. On the left-hand side, you have the window burner, and then in the bottom left corner of the right-hand photograph, you can see the burn room. So the burn room burner. So we have that burn room, that first level burn room, and then the second window burner, which is outside, lining up with the front of the window opening. What this does is this setup with two different burners exposes the interior face of the wall and the exterior face of the wall at the same time. So we've got that thermal insult from the inside and the outside. The test samples themselves, as Andy said, the original test was outdoor, one apparatus. You had to build it onto the wall apparatus itself. Well, now we build the wall assemblies in a frame. And what it does is it rolls into place on the face of the furnace. The photograph you see right here, right now, is without the front wall. So that is where the test assembly would actually be rolled up against that face. This allows us to really do multiple tests with minimal downtime between tests. We just have to wait for the furnace to cool if we can build all these samples in the test frames ahead of time. As Andy said, it can get quite smoky. So we're evaluating this flame spread in concealed spaces that we can't see with the naked eye with thermocouples. We're getting those temperature measurements at numerous locations within this assembly itself and within the room above the burn room to understand where the fire is going. So these temperature readings are used to determine the progress of the flame spread based on the temperature thresholds in the test standard when we can't see those fires.
So we've got two burners and increasing heat. How hot's this thing get?
Oh, it gets really hot. Most observers of these tests were actually going to be in a separate room altogether in the control room. And if those of you that are willing to go out there and witness it, the closest you're going to get is about 15, 20 feet away from it because of the heat generated from the two burners.
So you mentioned this is a two-story test. How's the second story involved in the past?
Yeah, that's correct, Paul. We do have two stories in here for a purpose, for a reason. We want to ensure that we have life safety and we're maintaining life safety for the people that could be occupying that space above the fire. We want to make sure that heat, smoke, and flames are not allowed to enter that second story. Now, there's a couple locations this can happen when you look at a slab edge and wall interface where that fire can get back into the floor above. Obviously, you can get into the wall cavity and you can burn vertically up within the wall cavity and then burn back through into the room above. You can also burn a hole through the entire cross section of the wall. So you got flames coming out from below, it goes up the exterior face and then burns all the way back through. And then we're also looking at that edge of slab. Now that's a whole different fire test standard, but that's a location we look at. Once again, we're looking via video and thermocouples to monitor those conditions in the second story to make sure that we don't have 500 degrees above at the edge and we're not getting any visible smoke in that space.
So if the flame and intense heat goes beyond 10 feet, that's a failure. So
correct.
Give us a comparison here. If you were to use a non-combustible material like concrete, how high is that flame and heat spread going to be?
Okay, so as you said, we're going to take take a concrete wall, nothing on it. What kind of visuals can we see based on the window burner and all that stuff? Just make sure I'm understanding your question.
Yeah.
The window burner itself will generate a fire plume of about 5 to 6 feet at the end of the 30-minute test. So you're getting 5 to 6 feet of flame extension just from the window burner itself.
Thanks. You keep saying assembly test. What does the NFPA 285 assembly test mean, and how is that different from a product test?
So when someone conducts an NFPA 285 test, you are evaluating the exterior wall assembly as a whole. And this doesn't look at a singular component. We're evaluating all the exterior wall components at the same time during this test, from the interior gypsum wallboard into the studs and the stud cavity space. We're evaluating the exterior sheathing. If there's a continuous insulation on there, we're looking at that continuous insulation and how it burns in conjunction with everything else. Even the air cavity space. In this example you see on the screen, the air cavity space between the backside of the MCM panel and the exterior face of the insulation all comes into play. Geometry, we're looking at this. And then obviously we're looking at the veneer system itself. So a holistic inside to outside evaluation. And as we've discussed before, a single burning material will behave a given way. But as we start to stack things up and we add geometry and we start burning multiple materials together, there's significant changes to the flame spread and the burning behavior of those materials. Now, in a product test, as I said, the only burning material in play is that product itself. Now, these product tests are typically smaller in scale. They do not incorporate large amount of material in its actual end use field condition. And when you look at it that way, that's why it's so important to look at the assembly test and why NFPA 285 is the approved method within the code of understanding and qualifying the fire performance of the entire wall assembly. Just recently, I've heard that even some of the European building code community have started to discuss and have started to rethink their methodology of designing exterior walls based on small scale tests in light of all these recent fires. And they're actually starting to reevaluate the importance of conducting more full scale tests of exterior wall assemblies as a whole to make sure that they're providing a safe environment for us to live and work in.
Great. Great. Thank you very much, Dan. All right. I think it's probably helpful for us to see one of these tests. Nick, I think you've got a time-lapse video of one of the tests, and if we can cue that up. Nick, why don't you walk us through what we're seeing here in this?
Yes, absolutely. So seeing the actual test definitely helps us understand it. So when we hit play here, this is an accelerated time-lapse video to allow you to see what happens. It takes the full 30 minutes plus 10 minutes to the post-burn. Right now, they have lit the interior burner, and here in a moment, you're going to see the flames right there just really pick up. And what that was actually they have lit that outside burner, and that's what's causing those flames to get a lot higher. Now, as this test progressed, as Dan was alluding to earlier, they're adding more and more fuel to the fire. They're literally increasing the gas flow so that those flames coming out of the burner will end up being 5 to 6 feet high, regardless of what material is on that wall. This simulates a real fire condition of that fire continuing to increase in its intensity. And as this goes on, you can see it is melting away and burning away the materials above that test, above that burner, directly where that's at. This goes off here in a moment. Once they reach the 30-minute test, you can see quickly there how the fire went out. I think it's a really important part of noticing what that FR material does. That went out because there was no more fire source, flame source. There were no sprinklers used. There was no fire extinguishers used. And this best demonstrates that fire retardant property of FR-MCM. The material is designed to self-extinguish, and that's why it suppresses that water vapor. And that's what we just witnessed here at the end of that test.
Thanks, Nick. I always love seeing that video. Dan, now that we understand these individual components of the wall matter, can you tell us about WRBs and insulation and how important they are and how they can impact the NFPA 285 test? And in particular, are they pretty equal, or does a particular type impact the testing?
Sure. For starters, there are several different types of water resistive barriers, or WRBs, out there. There are tons of different manufacturers on the market. The same holds true when you look at the insulation materials. These water resistive barriers typically traditionally cover the entire exterior wall surface, and they can account for a large amount of combustible material within the wall assembly. Just because they're not visible from the street doesn't mean we can ignore them from a flame spread and fire performance standpoint. They all burn differently, and they all kind of have different intensities when you look at them. You look at kind of the three main types of water resistive barriers that you're going to have. You're going to have the fluid applieds, which basically they spray it out of a giant bucket. You have the self-adhered sheet goods, so it's got a tacky backing that sticks it up on the wall. And then you have the mechanically fastened sheet goods, which just roll it out and staple it to the wall. And based on a lot of our in-house cone calorimeter testing, you see that the fluid applied WRBs tend to burn longer and hotter and have more potential energy than the mechanically fastened sheet goods. When you look at more of the exterior insulation materials, I mean, this could include spray foams, EPS, XPS, polyiso, the mineral fiber or mineral wool insulations, and they all perform different under fire conditions as well. Some will melt, some will drip, some will flow, others form a protective char layer and burn very slowly. And if you look at some of the mineral fibers, they just slowly decompose as they burn. Some of the organic binders burn away. But based on our years of testing and observing 285 tests and seeing them work in conjunction, the spray foams tend to be the worst performers. And then you get into the EPS and XPS foams. And as you work your way down, you get into your polyiso and mineral fiber. Now, something with basing experience, and we'll get into this later, of how we learn about combinations of materials. We know that if you take a spray foam or EPS or XPS insulation underneath an MCM panel, there's a 99.9% chance that you are not going to pass NFPA 285. It's just, we know that those combinations of materials just don't jive well together.
That's a lot of really helpful material, thanks. And so, but now I think the question, and what I'm wondering is, when is this testing required? So Nick, help us understand what triggers the NFPA 285 test. You're on mute there, Nick.
Yep. So Paul, you're right. It is a lot of information, and it can seem quite confusing. Ultimately, NFPA 285 is referenced in two different sections of the code. In Chapter 14, it addresses the facades and weather-resistant barriers, whereas Chapter 26 actually addresses foam plastics, which is the installations that Dan was mentioning. When reading through it, it can feel a little bit like a maze sometimes, but there are a few easy questions that you can ask yourself to get you going in the right direction. And I actually think this would be a great time to hand this over to Jeff Henry to walk us through that decision making. I know he and his crew answer questions like this when helping out with Design Assist quite often. So Jeff, if you don't mind, can you walk us through the series of questions that you would ask to determine if NFPA 285 is required on a wall assembly?
Yeah, thanks, Nick. As the MCM system fabricator, one of our jobs is to ensure that the wall assembly meets code. The first parameter to consider is built construction type. If it's non-combustible construction, types 1, 2, 3, or 4, then NFPA 285 must be considered. Next, I look at what's going on behind the MCM system. Is there insulation outbound of the sheathing? And if so, what type? If it's foam plastic insulation, then NFPA 285 is required. If there's no insulation outbound of the sheathing, then I look at the height of the building. Simply put, if the building is 40 foot or more above grade, then NFPA 285 is a requirement.
Thanks, Nick and Jeff. That seems pretty straightforward, but I noticed you mentioned some exceptions. Nick, what do you recommend to the audience if they have questions on their wall design?
Yeah, I recommend that you reach out. We have MCM fabricator, our MCM sales representative out there in the field that are there and paid to help in design questions and questions around this. I think Jeff would say the same around the fabricators. They are very educated and can answer questions. And you can reach directly out to the MCM Alliance and would be happy to answer the question. Our goal is to help make sure that we're maintaining that life safety as required in the IBC when you're designing with these great materials.
So we've covered the NFPA 285 in quite a bit of depth. Jeff, are there additional building code requirements for MCM cladding?
There is, Paul. ASTM E84, often referred to as just E84, is the standard test method for assessing the surface burning characteristics of building products. It's a test that's been around for decades, measures both flame spread and smoke developed of individual components used in a wall assembly. The results of this test classify material as Class A, B, or C. Class A material is required for high-rise construction, and materials that do not meet this classification often have difficulty passing NFPA 285 testing. The downside of E84 is twofold. The test is horizontal, and we know that critical performance is determined when material is in a vertical orientation. Also, the test is done on individual wall components, as Dan has mentioned numerous times throughout. And there's no way to determine that fire interaction of individual components between individual components when using this test. That's why the benefit of 285 is that it's an assembly test, and it takes both of these real world conditions into account.
Andy, you've been in the industry and part of the Metal Construction Association for a number of years. What's the MCA and the MCM Alliance done for the safe use of MCM?
Well, Paul, the MCA and the MCM manufacturers are focused on performance and safety. The best example I can give you goes back to 2000 and the initial MCM section that was put into the initial International Building Code. We had a section called alternate conditions, where limited use of MCM above 40 feet without testing to NFPA 285 was allowed based upon how other combustibles like wood, and vinyl, and plastic glazing are used in the code. After more than 15 years in the code, this section still proved to be very difficult to understand and use correctly. Even though limiting criteria like MCM panel size, panel separation, and percent of wall covering was very restrictive, the section continued to be misapplied. In the development of the 2018 International Building Code, the MCA proposed that this section be removed, even though the MCA was involved in getting it in the first place. This change was welcomed and included in the 2018 International Building Code. Another development by the MCM industry that started back in the 1980s was to develop something called an acceptance criteria for MCM.
Tell us more about the acceptance criteria 25, Andy.
The acceptance criteria was developed so that different manufacturers of MCM could have a common measuring stick to describe product performance. The criteria started off as one paragraph to describe the bond strength, and it expanded over the years to a 17-page document that now includes quality tests, physical performance, and fire tests. The document is used by the code people to develop the MCM recognition reports. In addition, the acceptance criteria and the building codes call for product labeling and third-party independent testing. The product labeling is the way to get the product performance information to the inspector in the field. And the third-party testing ensures that all testing is done using calibrated equipment in a standardized fashion. There are lots of details and requirements covered in that 17-page acceptance criteria, but we find it the best way to compare MCM products in the field.
So Andy, the IBC and the AC 425 require labeling. Now, as a manufacturer of MCM, Nick, are the labeling requirements that labeling requirements fall into your area, and tell us why they're so important and what they are.
Yeah, so yeah, they're definitely important. And Paul, they are in sections of the IBC 1406.14. They're also come up in 1703.1, 0.5. And ultimately, as a manufacturer, we're required to identify the product name, the total thickness, and identify the labeling program that we use for the product. At 3A Composites, we actually use a print line right along the back of every single panel that's produced. And this is really important because it allows the fabricator to identify the material, along with the code official to identify the material during the initial construction phase. And it also after the initial construction phase, should there ever be a need to replace a panel, such as damage on a panel or renovation of the project, you can simply look at the back of the panel, you can see the label or the print line on there and go back to the manufacturer and find out exactly what that material is, what material is used to make sure that we get it right from the start and get it right if we ever have to do it again.
Jeff, Nick mentioned the labeling is important to the fabricator. Can you give us your take on why it's so important?
Yeah, absolutely, Paul. We fabricate well over 1 million square feet of MCM material annually, which means that at any given time, there are several projects flowing through our operation. By having labeling on the back of the sheets, it helps us to ensure that we are getting the right material. It also gives our operators one more quality assurance reference. Additionally, it provides reassurance to the end user that they're getting a product that meets specification and code.
And Nick, Andy also mentioned third-party testing and code compliance reports. Why is this important?
Well, Paul, again, it is in the IBC and it's in section 1703.5. So that section comes up again, and third-party inspections are required. And really it's to maintain a consistency and a consistent level of market offering. So I look at it as basically a trust but verify type situation. A third party visits your manufacturing plant annually and they reevaluate the material you're producing is the same as that you had originally tested. If you change anything in your product, such as the core or any other component, a third party must validate that it still meets those same building codes. So sometimes you have a small change to your product and you actually have to go and retest them. And that's good to make sure that we're performing as well as we need it to. An example of this is an ESR code compliance report. And the code requires tests in the IBC to be performed to the highest standards through an accredited third-party agency. So again, this is a code requirement. And really, all credible manufacturers should be able to supply third-party, up-to-date third-party compliance reports.
It definitely seems like a good thing for manufacturers to produce what they are marketing. I want to switch a topic that I would like to touch on now is past or approved wall assemblies. Dan, does every wall need to be tested? It seems kind of impossible given all the potential designs.
Well, if anyone has about $500 million or more, and that's with a B, and nearly a few decades of available time, sure, we can test them all. But you're right, it's not realistic to test all the tens of hundreds of thousands of potential exterior wall designs. Now, I'm a fire engineer, but bear with me. Just like a structural engineer evaluation, we're not testing every building structure that we see to see if it fails before we build the actual building. Structural engineers conduct an analysis, determine the acceptable alternative combinations of materials, or we change out this column for this beam, or we change the location. So their engineering evaluations are used across the board. Now, when you look at it from a fire point of view in exterior walls, are the two main ways of showing compliance with NFPA 285 and meeting the intent of the code is to, one, actually conduct the 285 test, and two, is have an engineering evaluation performed that looks at all the materials and bases that evaluation on a successful 285 test. So taking a successfully tested test and comparing it to what's being proposed to see if those alterations are acceptable or not.
Go into that a little bit more, if you would, Dan. What are about engineering evaluations and why they're needed?
Yeah, so engineering evaluations are a means of taking that, as I said, successful 285 tested assembly and creating an acceptable alternate can't talk. It's been a long day. I apologize. Creating an acceptable alternate configuration with different materials, different thicknesses, different base wall constructions. These evaluations can take the form of a project specific evaluation, just specifically for a certain wall of a specific building, or you could see these in more of a generic evaluation that covers multiple building scenarios that you might find. We tend to call these build-a-wall letters. These evaluations are based on multiple fire tests, successful 285 tests. It's based on consultants' testing experience, knowledge of the actual tests that occurred, and knowledge of the materials and the burning characteristics of these materials to develop a technical justification for why these changes will not negatively impact the overall fire performances of the assembly. As I said before, these tests are expensive and time consuming, and engineering evaluations allow manufacturers to be able to market their product in multiple configuration, but it also allows you as the designer or the architect or the building owner or developer, designers, the flexibility when trying to spec out their building materials and sending it to contractors to bid. It gives you a bracketed of, okay, these are the types of insulations we could use based on a build-a-wall letter, or these are the types of water resistive barriers we could use in combination with the veneer we want.
So when's the right time for a project team to pursue an engineering evaluation?
I always say it's always better to go earlier. The earlier, the better. If you can't find a letter that's already out there, or your exterior veneer rep doesn't have something, the earlier the better. Get an engineering evaluation team involved. From you guys looking at compiling a list of the proposed exterior wall materials and some sort of exterior wall cross-sectional detail for that team to review. When, like I said, reach out to the manufacturers, see if they have a 285 tested assembly that matches what you're proposing already, and you're good to go. Or if they don't have that tested assembly that meets exactly what you've drawn up, start going down that path of an engineering evaluation. Remember, not every proposed exterior wall assembly can be supported by an engineering evaluation. There are combinations of materials that we're not able to support via technical reasoning and engineering certainty and engineering values. So at the end of the day, you still may have to perform a test to meet the option that you've designed.
So in instances where the assembly would require an NFPA 285 test, you and other fire engineers can make recommendations on what the designer could change to allow an engineering evaluation.
Yeah, absolutely.
Does engineering evaluation need any other approval, and is it officially allowed by code?
Yeah, I'll go back up to that first part real quick. Okay. on providing recommendations. My firm is not the only firm out there. There are a couple other consulting firms out there, including Jensen, Hughes, that can assist with working with the designers ahead of the game. We regularly work with installers and architects and building owners during the exterior wall design and material selection phase to look at 285 compliance. Now, every exterior wall is evaluated on a case-by-case basis. And as I said, we look at it from interior all the way out to the exterior veneer. We're looking at the studs, the insulation in the studs, the sheathing, the wallboard, everything. We utilize our decades of testing experience and industry knowledge of testing assemblies to assist our clients in developing design changes that would result in 285 compliant assemblies. As I said before, not all changes can be supported by an engineering evaluation. So the sooner you know that you have to run a test, the better, because of the long lead times. Now, circling back to your question.
To sneak 2 questions in there at once.
Yeah. Nope, no worries.
Let me repeat the second question. Okay. Does the engineering evaluation need approval, or is it officially allowed by code?
So at the end of the day, the AHJ, or the authority having jurisdiction, the building official, the boots on the ground local guy, they have the final say if they'll accept an engineering evaluation or not. Some jurisdictions we've worked with want to see a test report for that specific wall assembly based on a successful 285 test, even though you have an engineering evaluation that says it'll work. They just want to see a test. Now, you need to understand where you're working to what's going on. Some building officials allow build-a-wall. Some want specific engineering evaluations for that specific building. It all varies with where you're at. Now, is this pathway allowed by code? Absolutely. IBC section 104.11. It's the alternate means and materials section. Allows for the AHJ to review alternate materials and construction methods that satisfy the intent of the code based on supporting data, testing, and analysis.
Thanks, Dan. So last question. What is your one major takeaway for trusting the NFPA 285 and its pass for tested assemblies? And let's start with you, Andy. What's your major takeaway?
Well, I guess having been in the MCM industry for such a long time gets me to the front of the line here. I've been working with MCM and testing since 1986. And my one takeaway is that NFPA has been used for decades to show wall performance when exposed to breakout type fire. This performance standard has proven to be very accurate, and we have not seen any major fire involving a tested assembly. Could we choose or create a more difficult standard? Of course. But we have no experience that makes us concerned with using the results of NFPA 285 as an indicator for MCM performance on high-rise construction. Now, if we had more time, I could list a bunch of takeaways, but I'll give someone else a chance to add to the list. Nick, how about you next?
Oh, yeah. So I'm going to reiterate a point I made earlier, Andy, because I do find it so important is, the biggest thing is everyone, we're here to help. And if you have questions or need assistance, please reach out. Reach out to, members of my team, members of other MCM manufacturers, the sales representatives. They have lots of information. If not, they know where to go get it. On top of that, your local trusted fabricator, they're there for you. They're there to help work. And again, they want to make sure we do things right. And lastly, a plug for the MCM Alliance here. You can reach out to Andy directly or, the group in general, and we can get back to you with professional advice, or even the fire engineers such as Dan and his team and the others. So lots of people around to help make sure that we're doing things right and we're keeping North American cladding safe. And, we understand the code can sometimes seem confusing or difficult, or maybe you just need to get that reassurance that you did do it right. We're happy to help you there. So make sure to reach out and let's keep on designing walls in a way that promotes that life safety.
So Dan, you're up next. What's your takeaway?
So as I've reiterated multiple times, NFPA 285 and anything we do with exterior walls it's an assembly. It's a combination of materials that need to be evaluated together. It's not a component test. Changing one element within the exterior wall can have major implications on the fire performance of the assembly, either positively or negatively. And it's not just the material itself, but it's also the actual configuration, air gaps, stud spacing, anything like that. Also, engineering evaluations are an important tool in providing technical justifications for changes in the exterior wall assembly. When full-scale testing, you could have a 6-month lead time. You need to get an answer to your contractor now, or your building owners on you. Well, look at an engineering evaluation to see if that's a viable path forward. The other thing is we live in an environment where the things that we use burn. And how the IBC and the codes look at this is, yes, we acknowledge it's going to burn, but we want to limit that burning. We want to make sure that it doesn't spread uncontrollably up the outside of the building or back into the building. So we have that 10-foot requirement vertically and the 5-foot laterally from the center line to meet that code. Now, if you're a true code junkie like myself, the fire blocking requirements in the code allow for that 100 square foot area that you need to maintain in your spaces. Well, if you pass NFPA 285, you fall within that fire blocking requirement, and you actually meet the exception for fire blocking by passing 285. So yes, things are going to burn, but at the end of the day, we're limiting it to small areas that fire departments and fire service can get to extinguish the fire. Jeff, you're on the hook now. What do you got?
Last but not least, my biggest takeaway right now from all this is NFPA 285 is a test we all believe in. The effectiveness of this test is apparent by how assemblies that have passed NFPA 285 have responded to fire. And at the end, as an industry, it's important that we continue to educate everyone, the AEC community, on the effectiveness of this test and the benefits of MCM as a cladding material.
Well, and thanks to all of our panelists, Dan, Jeff, Andy, Nick, you guys are great. Appreciate it. I'm going to turn things back over to Tom, who's got a couple of closing comments, and then he's been combing through questions and is going to ask the panelists the questions that you all have raised. Tom, back to you.
Thanks, Paul. And wow, there's been a lot of information given out today. And it's really hard to summarize everything, but as you would expect, we do have a few takeaways. Number one, these catastrophic global fires have rightfully caused concern. And we have not had them in North America due to the focus of the IBC and the NFP 285 safety and no threat to life requirements. Important thing to remember that. Number two, involve a fire engineer early. Dan mentioned this. Early on in your project, particularly when you're going outside your typical wall design. Example, if you're designing a large wall cavity space, resolve it sooner than later. You'll definitely save your schedule. Number three, engineering evaluations are a great tool for designers. It allows flexibility for choosing wall assembly components, and they're based on science, and the IBC allows them in section 104.11. Number four, the NFP 285 test is required for wall assemblies containing combustible materials. There's no getting out of it, unless you can work it in with an evaluation, but they are required. And number five, the MCM Alliance is a committee within the MCA. We are focused 100% on MCM, and particularly on the safety within the MCM designs. We are here to help you when you need clarity. Please reach out to the MCM Alliance, your local fabricator, or MCM sales representative. We're only an email, or I'm a little old school, a call away. So in closing, I want to revisit the question asked earlier by me. Are we just lucky in North America? Well, luck has nothing to do with our current record. I think it's been shown today, and for the last 40 years, this industry earned the position with a lot of hard work by many driven and involved architects, engineers, fire consultants, MCM manufacturers, fabricators, and code experts. This is a very, very dynamic process, which counts on everyone's participation. And Dan mentioned that earlier too. Everyone is participating. My challenge to everyone on this webinar is to ask questions when you don't know or something's not right. Speak up, because people's safety and no threat to life is at stake. Cutting corners is not an option for doing the right thing. Buildings are built with combustible products, but not all combustible products are equal. And as discussed today, must be tested accordingly or not used no matter what the savings. Because there's no savings when safety and no threat to life is the goal. I want to thank you for attending today. We really appreciate your focus and attention. And now let's hear from you and answer a few questions. And we do have a few questions that have popped up here. And let's see what we got here. One of the questions that did come up was, why not design with just non-combustible products? And I thought I would throw that into Jeff Henry.
Yeah, thanks, Tom. It's a reasonable question. There are a lot of different building products that can be used, all that will help achieve the desired form, function, and budget to make up that, for your design intent, making up that entire wall assembly. But very challenging to find a combination of all non-combustible products that are going to be able to meet all of those requirements. For example, exterior claddings. There are non-combustible materials such as masonry, aluminum plate. They all have a purpose. But there's no one product that can do or achieve all things. For example, MCM. MCM is a great building cladding product. One, because it's cost effective, but two, it's coil coated. So that gives us a consistent finish across the entire elevation, where with other metal panels, particularly plate, at times those are post painted. You can see checkerboarding effect. Strength to weight ratio, the weight of that cladding product has a big impact on the type of building materials you're going to use behind that, from the studs to the subgirds. And so, the heavier the cladding material, the more robust the substructure needs to be. So that's a factor. As far as the size of the panels that you're designing that are driven off of control lines or floor lines, with MCM, you can get long sheets. 16 feet in length is a standard size, and you can even get custom length sheets. Now, I don't recommend designing a 20-foot long panel or even a 16-foot long panel, but the reality of it is that if you do have a large format layout on your job, an MCM is a product that should certainly be considered. And then the complexity of the building, the complex geometry that we see from one building to the next. There's just certain building materials that cannot navigate that complex geometry the way that an MCM panel can. So I don't think it's a one size fits all. I think if we just tried to design with solely non-combustible building products, we'd see a lot of the same similar style buildings being built, because we'd be limiting ourselves as to what we can really achieve. And the imagination is a great thing, and we're seeing that in the architecture today. And so I think that's, as long as we're aware of the code, and we're making sure that we are following that code and we're performing the appropriate test, then we can, non-combustible and combustible products can work in harmony with one another.
Thanks, Jeff. There's another question here. I'm going to throw this one for Dan. Why doesn't the NFP 285 change much over the last few years? I mean, we've had all these fires, and I think the question comes out that is, are we moving fast enough?
Excellent question. So that was a fabulous discussion that was had by the NFPA Fire Test Committee. I actually happened to sit on that, so I was front row seats. Prior to Grenfell Towers, the last edition of NFPA 285 was 2012. The NFPA Fire Test Committee 10, 15, 20 years ago decided to make NFPA 285 on a 7-year revision cycle. So that means every 7 years, we review the document, see what changes needed to be made, and make those corrections. Now, post Grenfell, post the Middle Eastern fires, the Fire Test Committee made the decision that, okay, 7 years is a little too long to be sitting around waiting to change this document on the NFPA schedule. So we have now made the decision to make the NFPA 285 document on a 3-year revision cycle. So 2019 came out with a new edition. We added in those vertical and horizontal joints and documentation of the window header as important things that we need to address and evaluate. But 2022 is going to be the next version of NFPA 285 out there for people to use and review. We have gotten through the second draft, so we're finalizing those changes to NFPA 285, and we'll have those more on a regular schedule to keep up with the ever-evolving world that we live in, to make sure that the standard is keeping up with the built environment.
Good. Thanks, Dan. Hey, Nick, here's a question for you. is there a significant price difference between PE and FR? And if not, why don't we discontinue PE?
Yeah, that is a great question. There is a price difference, and I think that really depends by manufacturer. So I don't want to speak to that. But in general, it's considered that PE can be cheaper. I think by scales of economy, some manufacturers are different. Some manufacturers, their PE might actually be more expensive than their FR. Now, to why does it still exist in the market, or why is it still sold? Again, I think that's reviewed by each manufacturer themselves to decide what they want to do. But there are some things that PE materials can do inherently a little bit better, I guess, than FR. What I really mean there is there's something called hot air welding, as opposed to using like silicone to attach. You can actually adhere the material to itself. But there are ways around that with the FR. So, I don't really think that necessarily is that great of an attribute. The one other thing that you could say is PE is slightly lighter at about 1.1 pounds per square foot versus FR being at about 1.5 pounds per square foot. But ultimately, Tom, every manufacturer makes their own decisions, and they have their reasons. And actually, I'll go back to that question in the actual presentation. When you look at signage and canopies, things that people aren't occupying, PE is a great material for those type of applications, and it does a great job. It does meet the lower than 40 foot with no other combustible insulation in it requirements for code. But again, most people are using FR today, and we really push FR at 3 AIA composites. So hopefully that.
I think I might like to add that to fabricate PE versus fabricating FR, there's really no difference for us.
Good. That's good to hear.
Good point. Good point. So, okay, Andy, question for you. FR products being required for high-rise installations, no doubt, or would they apply to single-story buildings also?
Well, and you heard Nick, that's a good question, and it's confusing often. You heard Nick talk about the buildings, the height of the buildings, and the height trigger is what really gets us. Above 40 feet, the rule of thumb is above 40 feet, you use the FR material, or above 40 feet, the Nfpa 285 test report is required. Below 40 feet, the ability to get out of the building, the ability for the flames to be contained, it's a lot easier. So the requirement is not there for Nfpa 285. And if you had a PE material available, that could be where you could use it in a lower rise type application. But keep in mind that the building code is a minimum standard. Somebody may be building a school or a hospital or a elderly care facility that there are some concerns for the occupants, and therefore they may say, well, I know what the code says, but I want a little bit more. So you always have to be aware that that option exists out there.
Yeah.
Yeah, and Tom, if you don't mind, Andy, I wanted to add, Andy was speaking specifically, I believe, to just MCM. Again, it was a wall assembly test. The thing about below 40 feet is there are other things that would spawn an NFPA 285 test, like a foam plastic insulation. And so, our goal is we just say use FR. To your point, your question earlier, the cost difference is not that much, and the benefit is, in my opinion, completely outweighs any kind of cost significance or cost in the market. So,
right, good. Thanks for that add in there, Nick. Dan, when an air cavity from the insulation to the back of the panel varies or generally larger than 3 inches, can the continuous panel extrusion be considered a draft stop in order to help achieve 285 approval?
That is a very loaded question. I see Andy grinning. It's like, oh, I'm glad Dan got this one.
Exactly.
The first thing I'm going to ask for is more information. What is that exterior insulation? Whose exterior veneer panel are you using? Has that panel been tested with an air gap greater than 3 inches? And has it been tested in an air gap greater than 3 inches with that insulation material? When we look at an NFPA 285 test, when we do an evaluation, whatever that tested air gap was, that's the maximum we're allowed. So exceeding that, we need to either reduce that air gap or we need to start looking at running a test with a larger air gap to see what happens. Changing geometries like that, is there a sweet spot where, hey, we're 5 or 6 or 8 inches away, doesn't matter? That's an excellent question. We are asking that same question. We're trying to figure out, is there a sweet spot? We just don't have enough test data right now to support increasing the air gap between the insulation and the MCM panel or whatever veneer it is beyond that maximum what was tested.
Good. Thanks, Dan. I knew that was a tough question, but good answer. Andy, do you happen to know the difference between the E136 and the E2652? This question came in to see if there was a difference.
Boy, that's a tough question. I know that the E136 is a test that's been around for a very long time, and it depends upon equipment that's also been around for a very long time. That's testing equipment. I know that there has been some changes in the manufacture of the equipment, the way the test is run and the way the measurements are taken. The new test, the new standard takes that into account, and some of the E136 apparatus aren't available anymore. So I believe that at the end of the day, the requirements turn out to be the same thing. I think the testing equipment is the variable in there. Dan, you want to add to that, or are you just going to nod your head? Okay.
No, I'm gonna second that. You hit the nail on the head. The pass-fail criteria is the same. It just comes down to the evolution of equipment and what's available and instrumentation over the years and the orientation of the furnaces being used.
Good, thanks, Dan. Now there's a question out here. I'm just going to throw it out. I'm not going to direct it to anybody, but somebody might have some experience in this. But has anybody ever seen 100% PE core MCM pass an NFP 285 test?
I think Andy and I can both answer that as a resounding no.
Yeah.
We know that the PE core will take off, and usually it takes less than 10 minutes, sometimes quicker, to make it to the top of the wall where the flame spreads up with a straight PE core. They actually ran one of those tests on the full scale 2-story 1970s test with the wood crib, and it didn't take long for that to take off, and we knew our answer 40 years ago.
We also, as I mentioned, I'm agreeing with you, Dan. We also originally, back before the IBC, had an additional criteria about heat content in the wall, and the PE test would not have, or the PE core would not have passed that test or met that criteria. So we figured, if you can't meet the small benchtop test, why bother with the tens of thousands of dollar full-scale test? I'm not aware of any PE test that's ever passed. I can't say that I've seen every test. I've seen a lot of them, but I haven't seen them. But I would question very much if it would have even a chance with the NFPA 285. So I would echo Dan and say that it just isn't going to happen. Okay,
I got one more question. What changes to the 285 are being discussed? And because this question, the person who asked this question, I thought he heard a rumor that a change was being considered that would render some or all of the previous compliant assemblies as no longer compliant. Has anybody heard that?
That sounds like an Andy Williams question right there.
I didn't ask the question.
No, the guy didn't answer it.
I think the reference that's happening here, I think what this person is referring to is the last change in the NFPA 285 was a fixed location for the vertical joint and the horizontal joint. You had to have one vertical joint from the window opening to the top of the sample within 12 inches, 13 inches of the center of the window. And you had to have one horizontal joint between 2 and 3 feet above the window. Now, you could have more joints, but what they wanted to make sure, what the committee wanted to make sure was they had what they considered a worst case scenario, because where that flame comes up, either out of the room or from the exterior burner, it's hitting that spot where those joints intersect. that's considered to be almost like an open pathway for the flames to get behind the panel. So they mandated that those joint locations are there. Now, and that's for the 2021 code. So if you're using the 2021 code to be compliant, I believe you've got to use, or my understanding is you have to use the 285, the 2019 version. You have to have the joints in the appropriate place. If you have a previous test, that test isn't going to help you any to be compliant with the 2021 code. But if you're using a 2018 version or a 2015 version of the IBC, those versions did not have the requirement for that joint. So you've got a little bit of flexibility as things transition forward. Now, Dan also mentioned they put a mandatory criteria in there for the metal that's used at the top of the window. That's because some people were using 040 aluminum at the top of the window and other people were using 1/4-inch steel plate. Well, if you're not going to manufacture or put this job in the field with a 1/4-inch steel plate, a test like that doesn't have any real meaning. So they're trying to get us closer to testing what's happening out there in the real world. Dan, you want to add to that?
No, I think you hit all the key points there on the head. Currently, the way that the building code for 2021 and 2024 as we're developing right now, there's been no proposed changes for any sort of retroactive allowances per test. So we are phasing in where these joints are important, and people prior to 2019, when the 285 test came out, they were already testing the joints in the appropriate location. So we're not completely eliminating every test that's out there. Someone may have run the test with the joint in the correct place before it was even in the code language. So we're not eliminating everything that's out there. It's just we're starting to phase things and making it a little bit more severe and make sure we're evaluating appropriately.
Dan, I would ask you this question. Here's a question from me, and that is, if I ran a test on an MCM material with joints in a different location, and now I have a project that's to the 2021 code, can you engineering evaluate a joints in the wrong location? Can you get that compliable today?
It depends on a few factors. One, how was it tested and where were those joints when it was tested? And two, another thing that I would need to look at is, okay, I need to look at the building. If I'm going to have panels somewhere, say I've got a concrete shear wall with no windows and I'm 30 feet above the ground where there's no car parked underneath or no chance for a dumpster underneath, and I just got this concrete shear wall up the face with no openings, could we look at it that way and be like, okay, there's no chance for an interior fire to get through the wall to the exterior and expose it? There's no chance of a major fire down on the ground to impact it. Can we still use that material? It's a possibility, but as I said earlier on in the presentation, it's a case-by-case basis. I've got to look at every wall. I've got to look at the surrounding area. Is there a building that's 5 feet away or 100 feet away? So are there possibilities? Yeah, but it's going to be a case-by-case review, and it may work, it may not work. We just end up asking a lot of questions to make sure that we are in a safe environment and we're putting up a safe design. So hopefully that answers your question.
It does. Thank you.
Hey, thanks, guys. I think we're out of time. In fact, we're on overtime right now. So I want to thank everybody that's participated, the panelists, the whole crew at MetalCon Live. Thank you. And I'm going to pass it back to Judy and Kaylin.
Perfect. Thank you all so much again for joining us, and to all of our attendees, thank you for being here with us today. As promised, and as we always do, you will be able to see the virtual recording of this webinar that will be live within 24 hours. You'll be able to see that both on metalcon.com, and we will also have a link to a YouTube page with that. If you have any questions about MetalCon, you can always reach out to us at info@metalcon.com. And if you have any further questions for our panelists, you can always reach out to us and we'll make sure that those get over to them. For all the questions that have not been answered, as you hopefully know, we will be sharing those with our panelists, and they, if anything is what they can answer, they will reach out to you. Again, thank you everyone for being here with us today. We so appreciate it. Have a great rest of your afternoons or mornings, depending on when you watch this. And again, our panelists, we can't appreciate you enough. Have a great day, everybody. We will talk to you soon and see you in a few weeks. Bye.
Thanks a lot.
Thank you.